Okay, good morning, class. So at this point we are looking at trigonometry, problem solving in 2 and 3 dimensions, 2D and 3D problems. So you guys had homework, you had to do exercise 1, the odd numbers, correct? Okay, for homework is going to be exercise 1, the even numbers. Okay? So, as promised, I'm going to do the odd numbers, and the even numbers will be selected numbers that you had problems with. So we are told that the first few basic examples to revise grade 11 work. Then we will use the double angles, the compound angles identity to find the final answer for problem. So the question says that ABCD is a building with tower DE. So that's a building, and that's your tower. Okay. Then we are told erected on top. The angle of elevation from A to E is 21 degrees, and the angle of elevation from B to E, this E, is 48 degrees. If the height of the building is 30 meters, the question says calculate the height of the height of the building is 30. Whoops. The height of the building is 30. They want to know what the height of the tower is. Okay. So if you look at what we have, okay, we have this being 30. So if you look at what can be solved at this point, is I can calculate BC. Nope, not BC. The height of the building is 30. Calculate the height of the tower. It's 48. What am I missing? Anybody managed to get this answer out? Huh? No. Just I'm going to pause this quickly. I'm going to have a look in the textbook. Maybe there's something we're missing here. Just check the textbook. Okay, so what we have here is that this 48, so I can work out this angle here. I expected the first sum to be a bit easier, but okay. So you got ABE is equal to 90 minus 48, which is 42. Okay? So we have a triangle looking like that. So with that, we know that is 90, so this whole angle AE or EAB is equal to 90 plus 21, which is, what 90 plus 21? 111, is that correct? 111 degrees. Okay. So with that information, I can go sine of E, over AB in other words. But then in that case I need to calculate that angle E. So AEB is equal to 180 minus 111 minus 42. This is going with sum of triangles. So it's 180 minus 111 minus 42, which is 27 degrees. Okay. Now we can say that sine of AEB over, so opposite that is going to be AB, is equal to sine of BAE over BE. And in this case I'm going to calculate BE. Just name the triangle I'm working in. It's in triangle AEB. Okay. I'm going to work out BD. Okay. Why do I need BD? So that I can work in this right angle triangle. Okay. You sanitize. Who's that? Oh, I thought you were in grade 12. Go bring. What's wrong? Mr. G, come in here. What grade you? Let's have a seat. Take out your maths. Have a seat, there's nothing wrong. Come here, see.
No, I do maths left.
How much I now feel? I feel rejected now. You're going to cry now.
You know, is the
Yeah.
it's not
Then I don't. Yeah, okay, so we go sine of A. The people this year you don't have to write it down. Okay. So you go sine of 27 over 30 is equal to sine of 111 over BE. You cross multiply, then I'll get BE sine 27 is equal to 30 sine 111. You divide by sine 27, it gives you BE to be 30 sine 111 over sine 27. So that gives us 30 sine 111 over sine 27. Gives us an answer of 61,69. Okay. That is 61,69. Okay. So now we can work in the other triangle. In triangle BEC. What we have is a triangle looking at this thing. There is 90. We got 48 here. We got C, E, and B. We got 61,69, which we just calculated now. Okay. So which trigonometry you're going to use your opposite and hypotenuse? Sine. So you go sine of 48 equals EC over 61,69. So EC cross multiply is going to be 61,69 sine of 48. Put that in the calculator. 61.69. That was the last answer calculated. So it's answer sine 48. That gives you 45,85 meters. Okay. Now this 45,85 is this length here. Okay, but the question is, what is the height of the tower? So therefore the height, which is ED, is going to be 45,85 minus 30, which is 15,85. Just check if that's correct. Okay. 18,85 meters for the height of the tower. Okay. Yes? Okay. Now I'm looking at number 3. In number 3 we are given the shape here. We are told that in triangle, let's move this up. In triangle QRS, we are told that SQR is equal to SRQ. We told that is P. In the other triangle, that is theta. We have a 90 degrees and we have a K. The question says prove that K is equal to that. K is equal to P sine theta over 2 cos squared theta. So again, as I said yesterday or in the previous lesson, that in order to prove my formula there, we start with the subject of the formula. You don't have to. It is going to be more simpler. Okay, so we're going to work in triangle QSP. Again, you don't have to write this and you don't have to draw the triangle here, but it just makes the way you see things a bit more clear. Okay, what can we say? We need to pick up K, and since QS is the link between the two triangles, I have to use QS. So I must use QS and I must use K. So which trigonometric function uses that? Tan. Opposite over adjacent. So tan theta is equal to K over QS. And again, we need to make K the subject of the formula. So K is equal to QS tan theta. So if you look at what is needed to be proven, only K is on its right place. We know tan can be written as sine rule cos. So what we do is we work in the other triangle. Okay, so let's work in this triangle. Okay, so now we say in triangle QSR. Okay, so what do we have here? We must pick up P. Why? Because there is a P in the formula. Yes. We have to pick up QS. Why? Because YQ is the link between the two. We're going to make QS the subject of the formula here. Okay? We got an angle. We got many angles here. We can work out this angle here. So it's definitely the sine rule. Okay? So let's go with, so we must first work out angle S in that triangle. So QSR, angle QSR is equal to 180 minus 2 theta. And why is this 180 minus 2 theta? Because that is sum of triangles, not so? And that is triangle QRS. Alright. Now we go with the sine rule. So we say sine 180 minus 2 theta is equal to over P is equal to sine of R, which is theta, over QS. Okay. So what is 180 minus theta? Which quadrant does that take you in? It takes you into the quadrant 2. So is sine positive or negative in quadrant 2? Sine is positive. So in other words, that is this is going to be sine 2 theta. Not so. Cross multiply, so QS sine theta is equal to P sine theta. Divide both sides by sine 2 theta. I get QS is equal to P sine theta over sine 2 theta. Okay. So what we do now is, we say, okay, let's take this, okay. You see now we've got QS in terms of P sine theta and sine 2 theta. Can you see that, people? So what I do is I replace QS in the first formula with that. So we can now say therefore K is equal to QS, which is P sine theta over sine 2 theta times what? Tan theta. So where does this tan theta belong? It belongs to the numerator. Okay? So it's tan theta. So is it okay? You see here? That can change. As you can see, that is not what they have ended off with. We can change sine 2 theta to what? 2 sine theta, cos theta. And tan theta can be written as sine over cos. So it's going to be p sine theta. Tan can be written as sine theta over cos theta. Sine 2 theta is going to be written as 2 sine theta cos theta. So what happens now? Sines cancel? Not so? So therefore k would be equal to p sine theta over 2 cos theta times cos theta. Cos theta. There we have proven what was needed there. Okay. Let's go to number 5. In number 5, we are told that CD is a vertical tower. CD is a vertical tower. Vertical means to say it stands up straight or 90 degrees horizontal. From A, the angle of elevation of D is alpha. From A, the angle of elevation is alpha. And from B, the angle of elevation to D is beta. Okay? The distance between B and C, which is the foot of the tower, is 5 meters. The distance between A and B is x. Find BD in terms of alpha and beta. So if they're looking at BD, as you can see, that's basically the link between the two triangles. Not so. So if we're going to work in this triangle here only, we are not going to pick up alpha as they want. Can you see that, people? They're going to pick up alpha as needed. Okay? So definitely in the other triangle we need to work. Okay? So we say in triangle ABD. So what we have at this point is a triangle. We've got A, B, and D. We've got alpha, X, and we must pick up BD. We must pick that. Okay? So if you look at what we have here, we have beta, which means to say we can calculate that angle there. And how can that angle be calculated? We're going to say that beta is equal to alpha plus ADB. Why? Because that's exterior angle of triangle. The exterior angle of triangle ABD. So angle ADB, sorry, is equal to beta minus alpha. Okay, so there we have this as well. So that's enough to use the sine rule. Not so. So we now say sine of ADB over AB is equal to sine of angle A over BD. Okay? Which now gives us, I'll take this over here. So now gives us sine of beta minus alpha over x is equal to sine of alpha over BD. Cross multiply, we'll get BD sine alpha. BD sine beta minus alpha is equal to x sine alpha. divided by sine beta minus alpha both sides, then BD will simply be x sine alpha over sine beta minus alpha. And there we got BD in terms of alpha and beta. Okay. In 5.2, now show that x is equal to that. So in other words, you must make x the subject of the formula. Okay? You see there's a 5 as well here, which means to say somehow or other they're working in this triangle here now. Okay? The 5 is being picked up as well. So we started by saying in triangle BCD. That triangle looks like that. It's 90, it's a B5CD. And there's your beta. So we'll definitely pick up BD. Why? Because we can replace BD with this here. Okay? And we need to pick up 5 of course. Why? Because the 5 is in the formula. Alright. So which trigonometric function uses adjacent and hypotenuse? Cos. So you say cos of beta equals your adjacent, which is 5, over the hypotenuse, which is BD. Okay. So what we do now is we say BD gets replaced with x sine. But before I'm going to replace that, let me replace it. So BD goes and gets replaced with that thing. So it's going to be cos of beta equals 5 divided by, or 5 over, x sine alpha over sine beta minus alpha. Which now in turn can be written as 5 over 1 multiplied by is reciprocal. Not so. So what we're going to do is we're going to tumble and times it. Okay? So it will become multiplied by sine beta minus alpha over x sine alpha. Okay? So what I'm going to do now is, in this next step, is to make x the subject of the formula. Let's make it look more like what is needed to be proven. Okay? Okay, I'm raising to keep the diagram in focus. We don't actually need the diagram any longer. Now it's just a matter of simplifying. Okay, so let's carry on here first. So that would simply be, I'm cross multiplying here. Cross multiplying. So that gives me x cos beta sine alpha is equal to 5 sine beta minus alpha. To get x on its own, I divide throughout by cos beta sine alpha. So x is equal to 5 sine beta minus alpha over cos beta sine alpha. And if you look at what do we have there, it's far from what that looks like. Not so. So what I'm going to do is I'm going to take sine beta minus alpha and expand it using the cos expansion for compound angles. That's why the sine. So if I do the sine expansion, that would simply read sine beta cos alpha minus sine alpha cos beta, or cos beta sine alpha. Not so. So in the next step, I'm going to put each one over its own. Okay? So sine beta cos alpha over cos beta sine alpha. That is the first fraction. Okay. What is sine over cos? Tan. Not so. So that can be replaced with tan beta. Okay. That is now minus. No, tan beta. I'm moving too fast. What is cos alpha over sine alpha? 1 over 10. Not so. So that would be over, so it's 1 over 10, so it's 10 in the denominator, tan alpha. Just look at this fraction here. Okay? So now we're looking at what would sine alpha cos beta over cos beta sine alpha be? Sine over cos is what? No, it can't be 10. Why is that not 10? The angles are not the same. Okay, the angles must be the same. So sine alpha cancels sine alpha, cos beta cancels cos beta. So what are we left with? 1. So I'm left with minus 1. And that's exactly what they wanted us to prove. Okay? That was number 5. So now we're looking at problems in 3 dimensions. We spoke about the common used sketches. Okay. Sheila and Desmond had outing. Then I asked you to do number 3, correct? Right. So in number 3, exercise 3. So here we are told that the figure represents the top of a sloping school disc. Then we are told that ABCD represents horizontal plane with dimension 60 centimeters by 40 centimeters. ABDF, which is the top, represents the sloping disc top. Calculate the angle between the horizontal plane. So what is the horizontal plane? This here, that's shaded, okay? The angle between horizontal plane and AF, the diagonal of the sloping disc, if that angle is FBC is 15. Okay. So if this is 15 here, okay, firstly, intra-angle AFC, that's 90. To work this out, that angle, I need this length here, which I can calculate. Did they give me the height of the sloping disc? No. Oh, okay, this is 50. FBC, okay, that's 50. And there we got 40 and another right angle. Okay. I was looking at the wrong angle, that's 50. But okay, here we go. So, as I said, what do we need? To calculate this angle theta, we need AC and we need FC. Okay. But as I indicated, we're going to work in a different triangle first. So in triangle ABC. Okay, we have a scenario looking like this here. It's a right angle triangle. How do I know it's a right angle triangle? Because this the horizontal plane is what? What type of shape is that? A rectangle. Okay. So it's a rectangle. So that is measuring 60 there and 40. It's actually the other way around. But it's the same thing. I don't want to confuse already the confused. Alright. So I'm working out AC, which is the horizontal. Not the horizontal, sorry, the hypotenuse. So AC squared is equal to 60 squared plus 40 squared. Pythagoras with angle B being 90. So AC works out to be 60 squared plus 40 squared. Is 5,200. The square root thereof is 20 root 13. We can work in decimal, but it's going to be a bit messy. So we'll just use it as it is. Alright. Then in triangle FBC, we have a triangle looking like this. Again, that's 90. That's 15 degrees. This is 40. We want to work out FC. Okay? So, which trigonometric function opposite and adjacent? Tan. So we go tan of 15 is equal to FC over 40. So we cross multiply. Which page is it? Exercise 3, page 126. Thank you. Okay. So we cross multiply, so FC is equal to 40 tan 15. So that gives us 40 tan 15. Gives us 80 minus 40 root 3. You can again work with decimal, no problem. Okay. That is 80 minus 40 root 3. Now, for this triangle here now, there is an triangle ACF. We have something looking like this. That's theta. It is A. C is standing at 90. F is 80 minus 40 root 3. That's going to be 20 root 30. So, which trigonometric function uses opposite and adjacent? Tan. So you say tan of theta is equal to opposite, which is 80 minus 40 root 3 over 20 root 30. Arctan thereof. So arctan, shift tan, whatever you call it. The answer was the last answer calculated over 20 root 13. Excuse me, 8 comma 4. Is that correct? Is that right? Yeah, okay. Thank you. Let's carry on. In question 3, we are told that Zandi is standing at point X. She observes two vertical poles AB and CD. The angle of elevation from X to C is 25 degrees, no, 20 degrees. And from X to A is 25 degrees. The distance between Zandi and the foot of pole AB is 15, which is marked 15 there. Pole CD is 5 meters high. First question, calculate the distance from X to A. Calculate the distance from X to A. So if we look at this here, that is what they want to calculate. Not so. So this is a fairly simple one. So that's going to be 25 here. This is going to be BXA. This is in triangle BXA. We have 15 here. They want us to calculate XA. So which trigonometric function uses adjacent and hypotenuse? Huh? Cos. So you say cos of 25 equals 15 over AX. Cross multiply. So it will be AX cos 25 is equal to 15 divided by cos 25. So AX is equal to 15 over cos 25. Put in the calculator. 15 over cos 25. Going to use 16,5. 16,55. Okay. Then we are told in 3.2, calculate the distance from X to C. That's what I want to calculate. Okay, so again, in triangle CXD, we'll have a triangle looking like this now. That's 20 D C5X. XC, so which trigonometric function uses opposite and hypotenuse? Sine, so it's going to be sine 20 degrees equals 5 over XC. Cross multiply is going to be XC sine 20 is equal to 5. Divided by sine 20 both sides. XC is equal to 5 over sine 20. So that's my calculator. Did I put 15 here? So this is wrong. No, it's right. Yeah. So we got 5 over sine 20. Going to be 14,62. 14,62 meters. Okay. In the next question we are told in 3.3, calculate the distance AC. So this is the distance we must calculate between the two poles if AXC is equal to 46. So we have two lengths and an included angle. So which rule are we going to use then? The cosine rule or the cosine rule. So that is in triangle AXC. Again, you don't have to write this part that I'm writing now. And you don't have to draw the diagram. But do please answer the question. Okay, before you now say, you don't have to do, you don't have to. So you don't answer the question. No. Please answer the question. Okay. So we say we're going to use the cos rule, which is going to be AC squared is equal to AX squared plus XC squared minus 2 AX times XC cos of AXC. Again, you don't have to write that. You're going to go on straight into the calculation, which is 16,55 squared plus 14,62 squared minus 2 times 16,55 times 14,62 cos of 46. In the calculator, the last answer calculated is 14,62. So 16.55 squared plus answer squared minus 2 answer times 16.55 cos of 46 gives us 151,48. The square root thereof is 12,3. Is that correct? Let's look at number 5. Number 5, we are told that in the diagram, AB is a vertical tower. Again, that's only 90 degrees horizontal. C and D are 2 points on the same horizontal plane as B. So there we assume that C and D is on the ground, or it is on the ground. Then we are told that C is 220 meters, CD is 350. The angle of elevation from D to A is 25. Then we are told that CDB is 36 degrees. Calculate AB, the height of the tower. Calculate the height of the tower. So for us to calculate the height of the tower, I need the length of BD. Not so that I can use the 10 ratio. However, I can work out BD in triangle BCD. Okay? So you got 36 here, you got 350, you got 220, you got C, B, D. Now we're going to calculate BD by using the Cosine Rule. So CB squared plus CD squared minus 2BC times CD cos of angle C, which is 220 squared plus 350 squared minus 2 times 220 times 350 cos of 36. The square root thereof, 220 squared plus 350 squared minus 2 times 220 times 350 cos of 36. The square root thereof gives us 215, 2. 215, 2. Okay, so it's 215, 2 meters. So from these simple calculation, we are in asked, no, didn't finish it. Huh? So in triangle ABD. So in triangle ABD, you have a triangle looking like this now. Is 90. That is 215.2. 25 degrees, that's D, AB. They want you to calculate AB. So which trigonometric function we said? Tan. So you go tan of 25 equals opposite, which is AB, over 215.2. Cross multiply. So AB is equal to 215.2, tan of 25 degrees. So it's 215.2 as the last answer calculated. Tan of 25 gives us 100,35. 100,35. Okay. 100,35. And the next question asks you to calculate the area of triangle ACD. BCD. So in triangle BCD, the area will simply be, and I have to draw in the diagram there already. To work out the area, I need two lengths and an included angle, which I do have initially. So it's going to be a half CB times CD sine of angle C. Okay? So that is simply a half times CB, which is 220, times 350 sine of 36. That is simply. Assalamualaikum.
Waalaikumsalam.
Apa?
Alhamdulillah. You?
Alhamdulillah. 350 sine 36. Okay, that gives me 22,629. Is that correct? Yes. 22,629,73 meters. For homework, I would like you guys, so on Monday, we're going to conclude question 7. And you're going to do for me the even numbers from this exercise as well. People in, yes? No. People enjoy the weekend. Good morning, class.